Taking off where we were at, we've set up the model with soft jaws for op 2 and we've made our stock for op 1. So make sure you've done that before you proceed with this tutorial. So what we're going to do is we're now going to go into the manufacturer mode and we're going to start machining. Now, one or more reference documents contains importable CAM data. We're going to hit no. So, I believe that's associated with the VISE. I'm not sure why that's coming through, but we're going to collapse down. So now we're in manufacturer mode. We're looking at op 2. We want to get back configured to where we're looking at op 1. So if we expand our models, and we're going to make the two soft jaws and the second instance of the Sierra generic VISE invisible, and we're going to go back to our first operation. Okay, and so there's our part, and we already aligned it, and the body for the stock was invisible. So here we are, what we're looking at. So we want to create our first operation around this. So let's go to highlight setups. We're going to right click on setups and we're going to create a new setup. We're going to set our z-axis orientation. We're going to do that off z-axis, and we're going to pick the top of the part, and then we're going to select the top left corner, or we're going to select a horizontal edge for the x-axis. And you notice it's making a volume around the entire model. It's including everything. What we need to do is go to select and select the actual body for the part. So if you don't have that expanded, show that. And that gives us a more realistic volume. At this point, you should have the X pointing to the right, and we're going to use a stock box point. So let's pick the top of the stock with the X pointing to the right. Now our stock size is incorrect, so let's go to stock. Instead of a relative size box, we're going to go from solid, and we're going to pick the model of our stock. It should math out to 5.72 or 5 inches 720 thousandths in X, and in Y 2 inches, and Z 1 inch. Okay, now we're going to go to the post-process tab, and we're limited to 5 numbers for the program number. So we're going to use the last 4 digits of the part number, including the dash, so 8661, and this is going to be program 1. And we're going to call this op 1, and we're going to put in notes VISE body. Okay, so we know that that's for the VISE body, and we're going to use work coordinate system 1. Let's hit OK. Now that we've set that up, we're going to go over to the setup, and we're going to call it op 1. And we're good to go. All right. So we're going to face this down first. We're going to go to face, and we're going to use our face mill. And we're actually going to bump the spindle speed up. We've had some finish problems that might help with. And then we're going to skip the multi-axis tab. We're going to go over to selected contours. We're just going to accept what we have there. And then we're going to go to heights, and we pretty much can leave all this at default. So it's going to cut from the top of the stock down to the top of the model, which should be 40 thousandths. Okay. Going to passes, our pass extensions. Let's extend that out a little more. Makes me a little nervous. So let's go 2 inches for our pass extension. give you a little more reaction time to stop that before it hits the part. And if our stock ends up being a little bit long, that'll help with that. We'll leave our step over at 2.0 whatever, and we don't need multiple depths or any of that stuff. We go to linking tab. The only thing we're going to do is remove this vertical lead-in radius, and then let's hit OK. Alright, so we got our one pass that's going to clean up the face. Alright, now what do we want to do? We want to clear out all the material around this. You can either use a contour command and do roughing passes that come in, or we can use a 2D adaptive clearing. I'm going to use a 2D contour. 2D adaptive clearing is great for these really complex parts with islands and stuff. But here I want to use a larger diameter cutter on the outside than I want to use on the inside. So I'm going to use a 2D contour. It's a simple contour. We're going to go and we're going to use our, from our aluminum library, we're going to use our 1/2 inch end mill. Okay, we're going to leave the default feeds and speeds. We're going to go to geometry, and we're going to hide the stock momentarily so that we can select the top of the chamfer for our profile. And then on the heights tab, we are going to go, the top is going to be model top instead of stock top. And because we've already milled down 40 thousandths. And we don't want to go to selected contours because that would end right at this chamfer. What we want to do is go to selection so that we can go past and pick the bottom of the model. Now another option is to do lowest of selected and have it model bottom. So if you do that either way, and we'll call that done. Okay, we're going to go to passes. Now we do need to do roughing passes around this to get down to the final shape. So we're going to first go to where, and then we're going to scroll down, we're going to click roughing passes. Our maximum step over is going to be 400 thousandths, and we're going to do 2 step overs. If we end up with any islands, we may need to increase this to more than 2 step overs. And then we're going to do multiple depths, and we're going to set our maximum depth at 1/4 inch, and we're going to do 1 finishing step down at the bottom, and that's going to be 0.01, and we're going to finish only at final depth. We're going to rough the final, we're going to use even step downs, and then we're going to scroll back up to this finishing step over. Let's set that at 20 thousandths instead of 50. Now we can go over to the linking tab. We're going to leave most of this at default. We want to select the box that says keep tool down. Our horizontal lead-in radius is fine. Our lead-in sweep angle at 90 is fine. Our linear lead-in distance at 50 thousandths is fine in this case. We're going to get rid of our vertical lead-in radius. We'll put 0 there. And if we want to make sure that we're able to see this thing plunge, we'd want to pick somewhere on the front of the part as our preferred lead-in position. So let's put it there. And let's hit OK. And this way it leads in from the edge. The main thing is we want to make sure that we've cleared out all of the material here. And it looks like we're cutting a lot of air, so let's go back and let's edit this, and under our passes, instead of doing 400 thousandths, let's do 250. Okay, and then our step overs are closer, so we cut a little bit of air, but we're still clearing out everything around this, so that when we flip it over in the soft jaw, the stock on the outside won't be affected. Now let's do the interior features. So we're going to go down to a smaller end mill to cut these other features. We also have these corners that we want to clear out with a drill bit first before we come in with our end mill. So let's do that. We're going to go in and we're going to do a drilling operation, and we're going to select from our aluminum library an actual milling tool to do our spot drilling. So we're going to hit the 3/8 chamfer mill, and we're going to select just the chamfer of each of our hex locations. Okay, we're going to go to Geometry tab. We're going to go from Model Top. We're going to go from whole top to whole bottom, which is going to calculate it at the bottom of the chamfer we made. And then we're going to go to the next step, and we're going to do a deep drilling with full retract. 0.06, so 60,000 steps. Again, this is just to clear the chip from the, and then we're going to dwell at the bottom for 1 second. Is that okay? Now we're going to go in with our drill bit. Now the drawing originally had a different diameter. Mine is modeled at the diameter of an engineering change. So our engineering change is the diameter of these holes is using the 177 drill. So we're going to drill, and we're going to select our tool from the aluminum library, and we're going to use the 1772 number 11 drill. Okay, and we can keep the default settings there. And we're going to pick both the faces and the holes. We need to select Okay, we got our holes, we got our cylinders. Now we're going to go to the Heights tab. And again, we're going to deselect stock. And we need to do something with the end condition. On the back side, you notice our drill point isn't, we didn't include the chamfer on the bottom. You'll get an error saying this feature is not reachable from that axis with the collision detection. So the way to get around that, instead of going to whole bottom, we're going to go to lowest of selected and model bottom, so that brings the tip to the bottom of the part. And then we're going to pick drill tip through bottom, so that'll bring the tip down through and cut to shoulder. And then we want to break through and go even farther, so we're going to go 0.03. So we're going to go a little bit deeper. That way we make sure we break all the way through, and it doesn't matter what angle the tip of a drill is, we've got some extra clearance we've built in there. So we've now drilled our 16 holes. And we go to our linking tab, and we're going to use the deep drilling full retract. 44 thousandths is fine, and we're just going to hit OK on that. Alright, so we've now drilled our holes. Alright, next operation. We need to cut the hexes and this counter bore at the end here. We're going to cut the counter bore first. This is a tight tolerance according to our drawing. We may need to cutter comp this to make this come into print. So if it comes in, if we use it to make this feature, then come back and make these two features with it, at least at that point it will be first in the code, and we can start the program from there. We're going to do a 2D pocket. We're going to select from our aluminum library the 1/4 inch end mill. We're going to skip the multi-axis tab. We're going to go to the geometry tab, and we're going to select the bottom of our pocket. Now we're going to go to the heights tab, and we're going to deselect stock top on both of these and select model top. We're going to go to the passes tab. We're going to deselect stock to leave. We're going to do multiple depths. Our roughing step is going to be 0.125, about half the diameter of the cutter for this because it's a tight tolerance thing. We're going to do one finish step down. Our maximum step over is set as 150 thousandths. We'll leave that and see how that works. Our finishing step down is going to be 10 thousandths, not 1 thousandth. We're going to use even step downs, and on finish passes, we're going to do wear compensation. We'll leave the radius the same. The smoothing deviation should be 0.004 tenths. One finishing pass, and the step over is going to be 0.01 10 thousandths. And you could repeat the finish pass as a spring pass, but we're going to leave that alone. Alright, we're going to go to the next tab. We're going to keep the tool down, make sure that's checked. Our lead-in horizontal radius, we'll leave that alone. 90 degrees is fine. Linear is fine. We might have to actually reduce that. Our vertical lead-in radius is going to be 0. We don't have room in here to do a helix, so we're going to do a straight plunge, which is okay in aluminum. And our plunge clearance is 100 thousandths. Let's change that to 50. And let's hit OK and see what we get. All right. So it's going around one rough cut, one finish cut every step. Okay, because this is tight tolerance, we do want to do finish on each step. All right, now let's go into our hexes. We're going to do 2D pocket. We're going to keep the same tool. We're going to skip the multi-axis tab. We're going to go to geometry, and we're going to select the inside of our hex. Then we're going to go to heights tab. We're going to change this to go from model top instead of stock top. And then we're not going to go to selected contours because our model is got that chamfer on it. So we want to go to the lowest of selected, and it'll be model bottom. And we've had some problems with flash, aluminum flash on the back side of this. So we're going to go a negative 0.005 just to make up for some cutter mismatch. It'll go beyond the bottom of the model by 5 thousandths. We're going to go to the passes tab. Maximum step over is fine. Smoothing deviation is fine. We want to do multiple depths. Yeah, we'll go ahead and do 1/8 inch steps in Z. We're going to do one finishing step down at 10 thousandths. We're going to use even step down. We're going to deselect the stock to leave. On our finishing passes, we're going to use wear control. Our smoothing deviation, for some reason, I don't know why this isn't populating, but 0.0004 4 tenths. We're going to do one finish pass. Our step over is fine at 25 thousandths. We're going to do lead-ins on all finishing steps. And I skipped the box here. We're going to finish only at final depth in this instance. It'll cut faster. Tolerance isn't quite as critical on this. And then we're going to go to our linking tab. It should be pretty much default from what we did. Now we might be able to fit a helix in here. So let's leave the helix where it's at. Except for our ramp clearance, we're going to set that at 50. Otherwise you cut a lot of air above the part. Alright, let's hit OK. So we get our helix in. We have a small rough cut hex, then another rough cut for the hex, and down at the bottom we should have a finish cut. Chamfers, the bane of existence. is we're going to do our chamfer milling. I have been using Fusion for quite a while, and I've always picked the bottom of the chamfer edge when it's modeled. Never had any problems until I regenerated this, and now it doesn't work. So let's go through this. Hopefully this works. The fact that these were pre-drilled might be an issue. It may not be seeing material to remove there. All right, so at the time of this recording, this was working. So we're going to do a 2D. We're going to do a chamfer. And we're going to select our 3/8 chamfer mill. Okay, we're going to leave all this at default. We're going to skip multi-axis tab and go to geometry. And we're going to select the top of each of these hexes and the top of our model. Then we're going to the heights tab, and again we're going to set this to model top instead of stock top. And we're going to go to the selected contour. And we're going to clear out this chamfer clearance parameter and leave the tip offset at 40 thousandths. And then we're going to go to the linking tab. We need to have the horizontal lead-in radius at 0, sweep angle at 90, and then we're going to hit OK. Okay, that is it for the machining of the first side, Operation 1.